here, it's smaller than the function values adjacent to it, can I say that it's a relative minimum? Actually, I can. I was just thinking for a second. So this value is smaller than the adjacent values. So this is considered a relative minimum. The function exists. All function values are larger than it. Also, if I move it up here, it will be a relative maximum because the function values exist left and right, and also they're smaller than it. Oh no. No, don't make me turn off my stuff here. Okay, now this one. It exists, the function exists left and right, so it's a relative min. This one is a relative min. Function exists on both sides, and also a relative max, and also an absolute max. There is no other function value higher than it. So it's a relative max because the function values exist left and right, and they're all smaller than it. And also it's the largest possible value of this function. This point, what is the problem with this point that we learned in chapter 3? What is the problem with this point? What do we know about the function at this point?
It's not differentiable?
It's not differentiable. The function is not differentiable here. Okay, it's still a relative minimum because the function exists on both sides, and this is the smallest value. So this, at this point, this is a relative minimum, and the function values exist on both sides, so it's a relative minimum. What about here? Relative max. Why? Because it's the largest value on this interval. The function exists on both sides. Adjacent here, smaller values than it. Adjacent here, smaller values than it. So this is a relative max. What about this? Nothing. It would have been, if it were filled in, it would have been the absolute minimum, but it doesn't exist. As long as it doesn't exist, I can't consider it an absolute minimum. Do we have any questions? Do we need to look at another, or can we move on to critical numbers?
Can you please look at another?
Okay. Any preference?
4.
Very good. So let's see what the question is here. State whether the function whose graph is shown has an absolute max, min, local max, local min. Okay. So since this point exists, this must be the absolute max. Oh, you said 4. So since this point exists, this must be the absolute max. This point exists, it is the absolute min. This is the absolute max and relative max. So here, this is the absolute min, not a relative minimum, because it's at the end point of the interval. This one is the highest point here. The function exists on both sides, so it's a relative max. Let's see on this one. This is clearly a relative minimum. The function exists on both sides and the relative minimum. What about this one? This point. So I cannot consider it a relative max because the function value here is higher than it. A relative max has to be like this, in the sense that both sides have to have values smaller than it if it's a relative max. I can say that, right? So on this side the function values are higher, on this side the function values are lower. So C is nothing. Both sides have to be smaller, or both sides have to be larger. So here both sides were smaller. The values here are smaller, the values here are smaller. That's why this is a relative max. But here, this side is bigger, this side is smaller. So I can say that this point is anything. Any questions? Anyone? Questions? Okay, so I like to look at critical numbers. So sketch the graph. No, we cannot sketch any graph right now. This is not part of what they should be doing at this point in time. Yes, we can sketch, but this is not what I'm interested in. We don't need that. So anything from 29 through 48. So here we're asked to find the critical numbers of the function. After we talk about critical numbers and the theorems that we need to look at, then we can go back and do some more graphing. But this is just algebra. There is nothing here that really involves calculus. So they're giving us an interval and they say, okay, graph a function. We're past that. That's in college algebra and pre-calculus. Okay, find the critical numbers of the function. So 29 through 48. Anything you want to choose from here, and we should choose at least 2, and find critical numbers, if they exist. Okay, I will choose then. I want to choose this one, 39, because it's ugly. H of t equals t to 3/4 minus 2t to 1/4. If you want to choose something else, this is the time. If not, I will work on this with you. Is that okay?
Yes.
Okay. So again, we are only asked to find critical numbers. Every time I'm asked to find critical numbers, however, I have to find domain, because I know that critical numbers come from f prime h prime of t is 0, or h prime of t is undefined. But the function h of t has to be defined. And how do I know if I don't find the domain? So the domain is mandatory whenever I'm asked to find critical numbers. That's the first step. And you can say this looks weird, and I would agree that it would be nicer if I do this. And the most important keywords in math, in my opinion anyway, are factor and simplify. Okay, no negative exponents, blah, 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 etc. So there are many more, but at least factor and simplify. And I could factor out, I could try to simplify, but for now I'm only interested in the domain. So what does this have to do? What does this have to do for the function to be real? We're not talking about complex functions in this class, so everything has to be real. So what is the condition for these to be real?
It has to be greater than 0.
Or equal to. We can always take the square root, the fourth root of 0, always, of any root of 0. So the domain of this function is 0 to infinity. If the derivative is undefined at a value here, then we have a critical number. If it's undefined at a number that is not here, then we don't have a critical number coming from this source. So that's why I needed to determine the domain from the get-go. Now, since that's my second step, I have to find the derivative. I will go back to this notation. I presented it like this because it will always be easier to find the domain than in the form of 3/4, power 3/4, or power 1/4. Maybe, for some of us. For me, it's easier if I write it and see the index, and I say, oh, okay, if it's an even index, this quantity has to be positive or 0, so then that's the domain. In this case, because if I have +1 here, then the domain is different. Okay, So I established the domain, and now I'm ready to differentiate this function. So we have h prime, bring down 3/4, subtract 1 from 3/4, bring down 1/4, subtract 1 from 1/4. And now it gets ugly. Again, please look at the function with no negative exponents, or better, factor and simplify it if possible. That's even better. Okay, I know that I can factor out 1/2. Both quantities have t, so t is in common. But the question is, what is the power? What power will I have to write in here?
-1/4.
Careful. So let's analyze something. Forget about this for a moment. If I have t to the third minus t squared, what power will I factor out?
T
T
squared.
squared.
Right. So the smallest always to have t minus 1 in parentheses. A same analysis with these two. Exactly the same idea. Yes, it's confusing, they're negative. Yes, it's confusing, they're fractions. But the method does not change.
-3, right?
Yes, it has to be the smallest. Always guaranteed. Okay, so from 3/4, I have 1/2 in front, so there is a 3/2 in front, right? 1 times 3 is 3, 2 times 2 is 4. From power -1/4, I subtract power -3/4. That's what I did here. From power 3, I subtracted power 2 to get power 1. From power 3, I subtract power 2 to get power 1. So from this exponent, I subtract this exponent, but it changes the sign. So I will have -1/4, but plus 3/4, which is 2/4, or 1/2. Any questions so far? Which means this is the square root of t. And then that's -1. Any questions? I will continue here. I'm jumping over all this and continue here. So 3, the square root of t minus 2 divided by 2, and everything over 2, and I bring the 4th root of t to the 3rd in the denominator. Any questions? Okay, so I can just write one more step, and I have 4, and the 4th root of t to the 3rd. This is the derivative. After all this work, I have to analyze h prime of t being 0, and I have to analyze h prime of t being undefined. Let's start with the easiest. For h prime of t being undefined, analyze this and say, yes, I know. What do I write? When is this undefined?
When the denominator is 0.
Yes. Why wouldn't you say that t, don't write it, I'm going to erase it. why don't you write why don't you say t cubed greater than 0? I know why you didn't, because we already established that the domain is 0 to infinity. There is no need to write something like this. We already know t is always a positive number. But what we have to write is indeed t equals 0. This is a critical number. Why? Because the function exists at 0. It's 0. Age of 0 is 0. 0 minus 0 is 0. Because the derivative is undefined, where the function is defined, t equals 0 becomes a critical number. Okay, now, when is a fraction 0? What do I have to write here? Just tell me the intermediate step. Don't solve it just yet. Just tell me what to write for everyone to see.
When 0 is on top. On
Yes,
the numerator.
exactly. 3 to the square root of 2 with t minus 2 equals 0. I move to divide by 3, so the square root of t equals 2/3. How do I solve this for t? What do I need to do? What operator I have to apply to both sides?
Square both sides.
Yes.
Square both sides.
So then t equals 4/9. This is another critical number coming from this source. So this function, as I mentioned, I promised, ugly, has two critical numbers. One coming from this situation, from this source, and the other one coming from this source. Functions don't have to have critical numbers at all. They may have critical numbers coming from this source and not from this and not from this, or even from both. This was an example of a function with critical numbers coming from both sources. Now you're going to ask, is this a max-min? I have no clue. Is this a max-min? No clue. We're not there yet. We will be able to determine. We don't know. Okay, since we have this function here, let's go back to my graph and also find out if these are max-min. So, for a max, what is the situation for a max? Positive derivative, zero derivative, negative derivative, or positive derivative, undefined derivative, not zero, but undefined, and negative. What is the situation for a minimum? Negative derivative, zero derivative, positive derivative. Negative derivative, zero derivative, positive derivative. This is a situation for a minimum. Or undefined. Positive, undefined, negative, undefined at this point, positive. So all I have to do is study the sign of the derivative left and right. If I see positive, zero, negative, I say it's a relative max. If I see, I'm going to put this in writing in a minute, positive, undefined, negative, I'm going to say it's a relative max. If I see negative, zero, positive, I'll say relative min. If I see negative, undefined, positive, I will say relative min. So I'm going to write this down and then we'll analyze these two, since we have it here. So this is called, notice what I said initially with node number 1 here. Positive derivative, increasing function. Negative derivative, decreasing function. So the first derivative tells us increasing, decreasing, and also max, min. Okay. So I think I put a node 3 somewhere with the critical numbers. Yes, I have 2 and 3. So I'm going to say node 4. 0 or undefined. So positive, negative, that is a max. Negative, positive is a min. Positive, positive, negative, negative, nothing. So if at a particular value, x equals 5, the sign of the derivative is positive, negative, that is a relative max. I want to write relative. It could be absolute, but definitely relative. If the sign at x equals 5, if the sign of the derivative is negative, positive, that at x equals 5, there is a relative min. If there is no sign change, there is no max min. So two things we learned from the derivative, from the first derivative, and that's all. Increasing, decreasing intervals, and relative max, relative min. So, coming back to our function, I'm just going to write it here. It was t. The interval 0 to infinity. And this is h prime of t. And we had 0, which is here, and 4/9 here. At this point, the derivative is undefined. There's nothing I can write here. At 4/9, the derivative is 0. I'm going to pick a number, plug it in, and see the sign. I'm going to pick a number, plug it in the derivative, and see the sign. Let's analyze this. There is no reason for me to plug in anything in here. What is the sign of this quantity no matter what? Remember, t is greater than or equal to 0.
Positive?
Always positive.